So, with last session, we talked about variables and constants basically being buckets that holds data. But what is that data? Well, that actually introduces today's session. That would be C++ types. Hi there, my name's Roy, and welcome to my Code Corner, where we take a hands-on approach to topics in computer science. And we are going to dive right into code. There is no definitions. Let's just jump right into it. So, if you were with us last time, you remember, real quick synopsis. Remember, when we define variables, there's a type and a variable name, or a type variable name along with the assignment and whatever it puts into. But today we're going to actually talk about those types. This is the things that you define in C++ exactly what goes in those buckets so that we can actually make this a type safe language and not get those crashes that sometimes do happen if you do bad things. So let's go ahead and start with numerical types. And of those numerical types, we'll start with whole numbers. Of course, a whole number would be any number that does not have that decimal part, so no fractions. This will be positive and negative and zero. And do our first type. That type, as we showed before, is the integer, an int. And we'll do your standard int number equals 0. Of course, what does this mean? It means we're going to put a 0 into this integer, this variable name called int number. Now, there are actually multiple types of whole number types. There is, and you will see why I'm putting them this way when we talk about this, but there is the short number equals 0. There is the long number equals 0. And then because we're dealing with a 64-bit machine, this is actually something new, the 2011 standard. There is the long. And for those that watched last time, you know I am actually doing everything here in camel case, where the first word is not capitalized, every word afterwards is, simply because that's kind of the standard way I like to do things. But you see, I have a short, I have an int, I have a long, and I have a long. All of them holding the value of 0. Now, the important thing to know is that typically this is not a big deal. Unless you're really working, really trying to constrain the memory that you're using. The only thing these have, well, what they have in common is that they all hold whole numbers, both positive and negative, and of course 0. What they do have different is when it comes to that bucket, when you define, how much memory you're using, each one of these actually holds a different amount of, or they utilize a different amount of memory. The smallest obviously being the short, then the next one being the int, the one after that being the long, and the largest one being the long. Now, I did make a comment when we were talking about word sizes on a machine that the largest a type can be is based on the word size of that machine. So that will tell me right now that this long, I know that's going to be a 64-bit or an 8-byte container. But what about these other ones? Well, actually, that's actually kind of funny because in C++, there's definitions, but those definitions are not set directly in stone. For example, if you look at a short, or it's also known as a short int, but most time you just call it a short. Short has to be at least 16 bits. That would be 2 bytes. A int, at least 16 bits, 2 bytes. A long, at least 32 bits, that'd be 4 bytes. And a long, of course, being that 64 bits or 8 bytes. But how do you know? Because as I mentioned, in the standard, it says it has to be at least. Does that mean it's guaranteed to be, like a short guaranteed to be 16 bits? No. Same way with the int. Does it have to be 16 bits? No. But there is a way, and I will show you. And one of the things that you will start, and the reason why I left up here, well, I left the limits too, why I left IOStream is so that we can use this cout. So we're going to print a lot of things to the screen just so we can actually understand what we're seeing. So what we're going to first do, let's do cout size of short. Of course, everything in the print, it's going to print just the way it is. I will show you that you can actually string together multiple statements as long as it ends in that endl. And I'm going to go ahead and end this line. But if you notice, I haven't put anything here. Well, that's because I'm actually going to show you there is a way to find out the size of any type, really. What you have to first do is you first have to define the type or declare the type. Realize that, I'll use define and declare kind of interchangeable in development. When you define a variable, that tells basically what type you're using. When you declare it, that's when you're telling the compiler to set aside the memory. Typically, this is all done at the same time. There are cases that's not done, and we will go into those down the path sometime, I don't know when. But really, most of the time you can just use those two terms interchangeable. But we have declared this variable short number, defined it as a short, given that's its type. It has a 0 in it. Really, we could have easily not put anything in it. It really doesn't matter, because all we're doing is we're declaring the variable, setting the memory aside. But how much memory? Well, there is actually a standard function in C++, and it's actually C also, called size of. And size of takes one parameter, that one parameter being that variable that we're mentioning. So I said short number was our variable name. I'm just doing the shortcut simply because why not? Don't have to type, because that means I'm not misspelling words. But I'm going to say, what's the size of short number? I'm going to go ahead and hit that run button. It will compile a code, just looking, making sure, yeah, everything here looks right. You do see this blue underline. That simply means that we didn't put anything into it. So this is actually known as an uninitialized variable, especially for a lot of these very primitive types, which are basically the basic types in C++. There are defined values that go in this. If you don't define a short, it's going to have a 0 in it. This is usually not good practice, and something that you might want to get used to is that whenever you declare a variable, go ahead and give it a default value or give it some sort of value. We don't really care here because obviously the program's going to end real quick. All we're doing is showing you can actually still have this with nothing in it and see what the size is, because the compiler actually defines the memory. So I'm going to go ahead and hit run, and it's going to go ahead and compile. It may give us a warning because we didn't assign anything to it. Warnings are typically okay. That looks good, and that does look good. And I noticed the size of the short is 2. And of course, what does that 2 mean? It means it's 2 bytes, which would be 16 bits. I said that it says the minimum number of bits that a short could be would be 16. In the case of this Windows compiler, the Visual Studio compiler, 16 bits it is. All right, let's go ahead and look at the other ones while we're at it. I could just copy, actually, let me do that so we can check them all out. We're going to go ahead and do every single one of these. We have a size of int, size of long, and the size of long. One thing I want to be very careful about, I did a cut and paste. Now this is relatively small amount that I'm doing, so I know that I'm not going to have a cut and paste error, but that does occur sometimes. So be very careful when you cut and paste code. I'll go ahead and get rid of this one. And we have a size of short, size of it, size of long, size of long. Of course, there's all of our size ofs. Again, of the variable names, we're going to hit run, and let's see what it looks like. And so we have, as we remember, we said that the value for a short was going to be at least 16 bits, 2 bytes. The size of a int was going to be at least 16 bits, but our int is 4 bytes. That'd be 32-bit. Size of a long is a minimum of 32 bits, which is 4 bytes. So that's right. And this one is interesting. The fact that an integer is 4 bytes here and a long is 4 bytes, so they're basically the same size. This is Windows. If you do this same type of thing on a Mac using Xcode, you'll actually find out that the integer is 4 and the long is 8. And the long in Mac being 8 bytes is the same as the long. So read your documentation. Make sure when you're setting this aside, of course, again, most of the time this doesn't matter unless you're really conserving space. The reason why you have so many different types that kind of hold the same value is because it's how big of a number you want to put into it. Because obviously something that's 16 bits, number that it can hold is actually quite a bit smaller than something that's 64 bits. Now, how would you know what that is? There's actually 2 ways. In the case of, or any of these signed types, divide the number in two. So in the case of a short, let's say that's 16 bits. So 8 bits, so it'd be 2 to the 8th. Of course, that would be the top end, negative 2 to the 8th minus 1 for the bottom end. You can do that calculation if you want, or there is another way. All right, so one thing, if you notice that each one of these, there's going to be a certain amount of precision that you can use. Short being 16 in our case, int being 32, long being 32, long being 64. Now, one thing, if you notice in what I've left since my last time I was filming this, my computer crashed, so I'm redoing all this over again. If I left this pound include limits, and what limits is, there's a lot of definitions on how big things can be. So one of probably the more common ones would be the minimum and the maximum for the integer. Shorts are, I've used shorts in the past. It's really when I really want to contain the memory, because this one is only 16 bits. Ints are pretty common, and you want to find out, is it big enough for me to use, basically. So what that limit file does, let me go ahead and, as I start typing, and I mentioned IntelliSense. That's a nice thing about Visual Studio. It does have IntelliSense, or if you use something like Visual Sys like I do, it has its own type of IntelliSense. You will see it's going to start trying to fill things in for me. And one of the things that down here in purple, you see int max and int min. Those are actually defines, and they're actually, if you actually select it, you can see the code pop up. You'll see a pound define int max and a number. That number being the maximum value that an integer can hold. Minimum, same thing. It's going to be the negative of the same version, minus 1. So if I did put like int max here, I can double click, it fills it in with int max. And instead of a size, let's just see what this int is. I'm going to go ahead and take that there away. I'm going to take the size of away. Press end the paren. And I'm going to have and comment these out so we don't confuse anybody. So what this should print is what is the maximum number of this integer. So I hit run, and it pops up with that number 214748367. Large number. That's basically a 2 to the 16th power. That's the easiest way to calculate. You can do the math if you want. I will say that especially raising the power to a multiplication in computers is a very costly thing. So if you don't have to do it, I wouldn't. But understand you can. And that's honestly what things like that limits header, that limits file for. It defines things like this. Now you kept hearing me talk about these are signed numbers, which means they go so far to the left, so far to the right, has a 0, but the left will be all the negative numbers. What if you want, let's say you want a number that is 32 bits. You don't care about anything that's negative. What you can do, just like you have these numbers here, there is a reserved word that you can put in front of these that will change it slightly. If you don't care about negative numbers, you can turn these short, int, long, and long. Go ahead and change this int max of gone again. Put that back to 0. Copy the code. Because all I'm going to do is put unsigned. And that will turn a signed type to an unsigned type. Basically, it means no negative values. Now, when I do this, I'm going to compile this with the knowledge that I'm going to get an error. I'm going to show you so you can see what we're doing. Of course, the assignments are all the same. All I did was put unsigned in front of every one of these variable declarations. So when I hit this, watch for the error. And it popped up. Yes, there are errors. Do you want to run the last one? No, I don't. But what are those errors? This was what I mentioned last time when we were talking variables. When you declare a variable, it declares a piece of memory already, and it gives it that name. You cannot redeclare a variable. The only way you can do that is there are special ways of doing it, but in this case, like right in this one function, since I have a short number, I cannot have an unsigned short number because that would basically be the same name pointing at two different pieces of memory. So I have to do something a little bit different on each one of these. I'm just going to put a U at the end. And so when I hit this, it makes every one of those the same. Of course, you still see that integer pop up. So that means my program still ran, but every one of these variables are different variables. So I have 4 variables holding signed numbers, 4 variables holding unsigned numbers, and I did get a couple of these warnings basically saying I used something, an unreferenced local variable. Basically, I didn't put anything in it. I just defined something in memory and just said, I don't want to use it. It's perfectly fine, but you will get those warnings. Understand that warnings when you build code doesn't necessarily mean you have a problem. It means it's basically there to catch your eye. It means something may be off that you got to think about. You may look at these warnings going, you know what? Yes, I know I didn't put anything in short number or short number U. I don't care. This is not going to hurt the program. Just move on. But sometimes you're going to run into things that it will be a problem. Matter of fact, let me show you. Yeah, I'll show you one right now. So I'm going to go ahead and comment this one out. Now, when you declare a variable, which is what we're doing, we declared a variable and we put a number into it, right? We put zeros in everything except short number and short number U. But let's say I want to put something into short number. And what do I want to put in a short number? Let's say I want to put int number. So that is simple. We already have our assignment operator. And so what I'm going to say, I don't want to put short number U into it. I want to put int number. And so basically what I said is that I have this variable. I want to put the value that's in this variable into this variable. Now, if you remember correctly, when we are looking at the sizes, this is 16 bits, this is 32 bits. So what would happen? And of course, this one has nothing in it. This one only has a 0 in it. But what's going to happen? So I'm going to hit run, and it's going to run. And of course, we took out all of our cout, so we're not going to see anything there. But what did we get? Comment this one out. Run that again. Interesting thing, it did not do it to me. But what we've done here is, sometimes you'll get a warning on some compilers, sometimes you won't. I'm actually surprised we didn't. But when we've taken a 16-bit variable, so basically 16 bits of memory, and we tried to put 32 bits into it. So let's say, I did that. Let's say I did do that int max, right? And so if I hit, will it actually give me an error this time? No, it's still not doing it. Interesting. Sometimes this stuff even amazes me when you don't get an error. This one should have gotten at least a warning, because what's going to happen is this is 32 bits. If it's int max, it's basically going to be 16 bits of ones. What it will do is it will take the rightmost 16 bits, put it in here, everything else, it just throws it away. This is actually known as implicit casting, where we're taking the one type and putting it into the value of another type. What you have to be very careful about is when you're implicitly casting something that's larger and putting it into something that's smaller, because what happens is that cast will throw bits away. And so you may actually see a number that might have been large when you put it into a smaller variable, like an int into a short. It will get rid of 16 bits, and those bits may be significant and will change your program. So be very cautious about this. This is a very good case of problems in code. So again, be very careful about this. And of course, you can implicitly cast. Implicitly casting from a small number or a small variable type to a large one is not a problem, because it would just fill the rest out with zeros. But when you go from a large variable type to a smaller one, you will lose precision. You will lose bits. Be very careful. Also be very careful when you're in this case where you might be taking like an integer, a signed integer, which means it's plus or minus, and put it into an unsigned. So I'm going to actually let's do that. Let's put int number and put it into short number u, and let's see what happens. See if this one gives me a warning. Nope, still no warning. And actually, what I'll do, let's have a little fun here. Go ahead and take a look at, you know what the integer is, u short, and of course we have to change these out. It's just a spelling thing because u short's not a real word. I'll just put a space here and make it go away. It's not a real error. That's actually the red. You got to be, especially when you're dealing in an integrated development environments. Sometimes those red squigglies or whatnot will tell you that you're doing a syntax error. Sometimes it's just telling you you're doing a spelling error. So be very careful about that. That one throws me off all the time. I'm going to go ahead and hit play here. See what our three types are. And of course, we had that integer, that max int. Of course, this is max signed int. Short, we see it's a -1, which is interesting. And unsigned short, we see it's a 65,535, which is the largest. This is 2 to the 16th power. So again, we put this integer in these two different types, and because of the way it throws bits away, you see that it changes the value. So be very careful when you do implicit casting. And why it didn't throw the warning, usually it does. That one actually surprised me. I wonder if that's something new in this compiler. All right, so that is everything when it comes to whole numbers. So that is, you have the four signed types, and you have the four unsigned types. Really the only difference is the unsigned would have this unsigned in front, but other than that, it looks exactly the same. And of course, always go ahead and put in your, look at the size, either look at the documentation, or you can always use the size of to tell you how big is it. So that's everything for whole numbers. Let's move on to the next type. And of course, these would be your decimal numbers. I want you to understand this stuff very much because we are going to get into the operations on this. And especially when you're dealing in different types, and implicit cast. We'll talk about explicit later. Things can get kind of hairy, especially when you're dealing operations between whole numbers and decimal numbers. But right now we're just going to cover the types. But there are actually two different types when it comes to decimal numbers. There is the float number, the 0.0. You don't have to put the 0.0. It makes perfect sense. If you put 0.0 up here, it's going to drop the decimal part. If you just put 0 here, it's still going to say .0 when you print it. But get used to, especially as you start writing code, when you start seeing that, okay, I've got a float number, we're going to deal in floating point values here. The other one, and this one is the one you'll see more often, is double. When it comes to floating, or basically decimal numbers, and I will typically call them floating point numbers, even when I'm referencing doubles. How that data is laid out is actually an IEEE standard. It's actually IEEE 754 for those that are playing along at home. There is a binary 32-bit version of that. This would be your standard single precision. And then there's the 64-bit double precision. When it comes to decimal numbers, the floating point is 32 bits. The double is 64 bits. Now, how does that lay out? It really depends. When it comes to your standard, your 32-bit, the first bit is always your sign. Then the next 8 bits would be your exponent. That would be everything that's on the left side of your decimal number. The next 24 bits, 23 explicitly, would be, and that's because one of your bits is your sign, that would be your decimal part. When it comes to your doubles, first bit signed, exponent, which is your left, would be 11 bits, and then the other 52 bits would be your decimal part. One thing that kind of, if you think about it, that's a little bit different than when you're coming up here, is you have a 1 bit dedicated to your sign. Your unsigned and signs up here do not dedicate 1 bit to sign. It's really based on where it is. You know, if it's all, let's take your short. If it's all ones, we know that's a negative short min, or short min, which would be negative. Same with max, whatnot. If you know the left half is be your negatives, and then right half would be your, and I'll show you the bits and another time when we really start going deeper into this. But your negatives is kind of built into your numbers. When it comes to your floats and your doubles, they always have that 1 bit dedicated, and that's part of the IEEE standard. They have that 1 bit dedicated to your sign. What that does do, which kind of throws people off a little bit, it means floating points and doubles can have -0. So you have to prepare that you may have a positive and -0. There is 2 different values. It's really based on that sign bit at the front left, far left. And when you hear me talking about bits and far left and all that stuff, understand that as I think of bits, basically your most significant bit would be to the left, and you write it to the right. As a matter of fact, and I forgot to mention this here, when it comes to these whole numbers, there are different numbering systems. Actually, when it comes to computers in general, we always talk in decimal, or that would be a base 10. It's how we've always done math. It's how we really think. Computers really don't think that way. As we mentioned before, computers are made up of bits, and they hold a 0 and a 1. So binary is kind of the de facto language of computers. But even if you're not talking in binary, things are always in some sort of power of 2. So you might have again, binary 0 and 1. You'll have octal, 2 to the third, sorry. But it's 0 through 7, and then it moves up to the next number. So it's 8. And then you have hexadecimal, and that would be 0 to 9, A through F. You'll get used to talking this way. You'll also get used to converting. You're going to see things like addresses, and addresses are typically in hexadecimal. You'll see some of the things when you're talking networking. A lot of that's going to be in octal, or you're going to look at dumps, stack traces and whatnot. A lot of that data is going to be in binary. So being able to switch between the different numbering systems becomes kind of commonplace. I am in the process of building a video specifically on that. May even do a few shorts just for the quick, easy ones like that, binary to decimal, decimal to binary, whatnot. But understand that that's how computers think. And because computers think that way, you can actually, when you're dealing in number types, you don't have to put it in decimals like I did here. You have int a equals 10. That's easy. It's not a variable I'd use very often because it's 1 letter, but this is for training. But I could just easily say int a is 10, or I could say int b equals, if I look at this, how do I know that's 10 and not binary? Well, the easy way is because whenever I talk binary, I actually start everything with a 0b. So in that case, let's say 0b10. This is actually, if I convert it to decimal, this would be 2. Because it'd be 1, 2, 1, 1 would be 3, so on. Again, you'll get to using this down the road. I could say if I cared more about octal, which is again, 0 to 7, how do I know that what this is octal? I always start this one with a 0. So if I wanted to write 071, what's this equal? This is actually octal, converts to decimal 8. What about hexadecimal? Because I might want to write stuff in hexadecimal. How does that start? Everything starts with a 0x. This one's nice. This was actually, there's 4 bits here, there's 4 bits here. So this is 8 bits of 1s. Nice thing is you don't have to, you can write this standard. You don't have to do anything special other than those first numbers to tell the compiler what to convert it to. The computer will just do it on its own. Matter of fact, if I start asking it to write this out, let's say I want to, and instead, if I want to say, okay, print out A, that should be 2. So if I hit play, oh, my bad. I chose A, which is actually the decimal one. If I wanted to see what the binary one is, I want to see B and print it out. It should now print out a 2. Yes, because it's automatically printing them out in decimal. And the reason it's doing that is because I'm not telling it to print it in any other way. It's printing it in what it thinks I know best. There is ways to do it. When we get into the IO stream, we will go deeper into it. If I print C, 071 converts to 57. Oh, my bad. When I was saying 8, that should be it would have been 17, not 71. And then if I wanted to see D, that should be, is that 255? Yes, 255. And the reason I know this is that how many times when you're setting a subnet, if you want to do 255.255.255.255, that translates to ff.ff.ff.ff. Yes, I've done this a few times. And so again, computer will do it for you. You can do in these other different ways. You can also put these into floats and doubles. I would not suggest doing that unless you absolutely have to, because then you're going to actually have to do the conversions and all that type of stuff. When you're dealing in floats and doubles, deal it with the number, understanding that the float is 32 bits, the double is 64, and they follow the IEEE 754 standard. And so these are the number types. So these are your whole numbers, and of course your decimal numbers. So easy, there's not many. There is ways we're going to expand these later in the derived types and your unique types, but you can actually do a lot of your programming just with these when it comes to numbers. But of course, not everything that we do in computers is numbers. There are a few other types, and I'm just going to put these in a category of other types, because we're not going to talk a ton about these, but we are going to, I do want to, when you see these, understand what they mean. And of course, that first type that we're going to do, and I think we saw it right there at the beginning, you see this thing called char. Char stands for, char is a character value. This holds one character. Now, what do I mean by character? Now, when you assign a character in C++, you can't just drop a number in it, because that doesn't jive. What it assumes is that it will hold any character. So if I want to put, let's say, an A here, will this compile? No. The reason is because it doesn't know what an A is. You actually have to surround it with ticks. And this tells you that this is a character value and it holds a literal A. And if I actually see out character value, I'm turning off all these other see outs so we don't confuse anything, it will print an A exactly the way I put it in there. If I want to put a number in here, because this is the literal thing you're putting in. Let's say I want to put a 5 in there. I surround it with ticks. Put that in there, and what's it going to print? It's going to print a 5. What happens if I don't put the ticks? I'll show you. It doesn't print anything, because it doesn't know what this is. Actually, what this does is it turns it into a binary number. It does put something here, just nothing that you can print. So understand, when you put a character in, surround it with ticks. Therefore, you know exactly what's going in. That's a character. Now, how big is this? I'm going to jump into our handy dandy size of, and it will tell us that it is exactly 1 byte, 8 bits, which makes sense. That's if you think about it, when you're writing, each one of these characters that you're seeing here is basically controlled by 8 bits. That is wide enough to go into what's known as the extended ASCII set. And we can talk ASCII later, but understand that is 1 byte, 8 bits. The next thing, and we'll talk more about characters, and what's even more is the derived types from character, because obviously you're not going to have a ton of this to fill words and stuff like that. There is better ways. The next primitive type is the bool or boolean. And boolean, actually, there is a pretty standard way of writing boolean variable names, and that would be you write these as you would read it, because a boolean type, booleans is on or off, right? In the case of when you're defining a boolean, it's actually true or false. Actually, you can see it's even put right here. You see true or false. So in this case, we'll say I have a boolean variable by the name of isBoolean, and isBoolean, it's true. So it's almost read as you're asking a question, because we'll use these in about 2 sessions. I'll show you a lot of the operations that we do with boolean, but you do this more, you read it as a question. Is this variable boolean? Is this a boolean? Yes, it is. What's interesting about this one is how big is a boolean? Because if you think about it, boolean, true or false, it's a binary value. And so you think, well, it's a binary value. It's only 1 bit, right? Well, let's see. It's 1 byte. And if you remember last session, one of the things I would talk about is that bits, you can use bits, you can get to bits, but the most addressable piece of memory is a byte. So even though this is consuming 8 bits, and only one of those, I'll give you a little secret, only one of those bits in this byte is used. And we're going to talk about how to get to those individual bits later, probably in 2 or 3 sessions. I don't know, see how it shakes out. But we're going to start talking about things like flags, and that's what this is. It means that there's one flag somewhere in these 8 bits that's getting set. It's either 1 with a true or 0 false. To the point, and this is, I would never recommend doing this. You'll see this a lot more in C code, even though C doesn't have booleans. But I can set where it is boolean, and if I actually C out is boolean, if I set this to 1, it should tell me it's true. It tells me it's a 1. And let me put true here. What does it tell me here? That actually may tell me it's a 1 also. Yeah. So you see true and 1 means the same thing, because true, 1 on. And if this was a false, this will be 0. Yeah, false is 0. Or I can say is boolean equals 0, and that will also tell me it's false. 1 and 0 are the only numbers I can put into a boolean. Let's say if I did something like is boolean equals 5. It will tell me a 1, but it also gives me this warning that I am doing a truncation from int to a bool, which means again, this should have been what was up here when I was doing the implicit cast. This is also an implicit cast, and it's actually telling me that I'm dumping data. Why it didn't tell me up there, I don't know. That still surprises me. That is true. And then there is one more type I'm going to show you, and it's a type you cannot use for variables directly. But you will see in a lot of function signatures and whatnot. Again, another topic we'll talk about here pretty soon. But you may see, not vopid, you will see the term void. And I'm going to call this one not valid. Void is used, it is a type, but it's a type that means it is nothing. Again, a lot of times when you're building function signatures, you'll see void. There is a way that you can break type safety. Not directly with a void in this way. There is another way of doing it. When we talk about pointers in quite a few lessons from now, we'll talk about that. But if I compile this actually will not compile, because you cannot declare anything of type void. So while void is the valid type, it is not a valid type to declare as a variable, because it means nothing. It is the void, right? This is a black hole. So yeah, this is it. This was a kind of a crash course. So let's go back, look at summarize, and figure out where we go from here. All right. So this was a long lesson. I'll tell you, while it does sound a little complicated, thinking there's a lot to remember here, realize that I'm trying to explain a little bit deeper of what these are. As you program more, as you use these more, you'll find actually these become very common knowledge. It's why it's the foundation of languages, understanding the type. One of the reasons why I definitely like going deeper in understanding why so many bits when you would use a long compared to an int or doubles, floats, those are easy. Why I go deeper into it, I've done a lot of work in optimization and in systems where the resources were extremely tight. So a lot of what I'm showing, while most of the time you probably will never use integers, you might use integers or a long maybe because you need a number so wide, or you'll use an unsigned long because I don't really care about negative values. Most of the time you're not dealing in numbers that large. And so choosing, do I pick a short over a long, over an int? These are design decisions. And it's really based on what you're trying to build. In a lot of cases, an int's going to be everything you need. Doubles are a little bit different. Doubles are typically your de facto, what everything falls into. You really only constrain, you don't use floats because it does constrain your precision. And then chars and bools, you're going to use a ton of. So those are all the basic types we've talked about. Of course, we talked about void and we're not how you don't use it. You'll see it, but I just wanted you to understand that's what we'll talk about later. I did show you a little bit about implicit typecasting. In the next session, when we talk about numerical operations, we're going to use every single one of these types again. And of course, not only the int, short, long, double, float, we're going to use the unsigned versions of it, because sometimes when you go from one variable of a type to another variable of a type, you got to understand some of the nuances that might get you caught up, things that may actually add bugs to your code. And what I want to do is try to make you think about how to not make bugs. So we are going to go very deep into implicit typecasting. There's a lot of this when it comes into numerical operations. We'll also talk explicit typecasting at the same time, simply because sometimes you can't do numerical operations without it. So hopefully I didn't lose you. This one, again, being very fundamental. I won't say necessarily every other lesson is going to be easy. When we get to things like pointers, I remember back in college when I was studying C, pointers was one of those sections that as probably most of the students dropped after understanding pointers. Once you understand that, it's not a big deal. But this one is being so early in a language, it seems like a lot. This will become just core knowledge really quick. So I hope you enjoyed this. If you've got any feedback, one of the things I will ask is, especially for the people who might be watching this on a phone, I mean, computer, TV, it's probably be fine. If you're watching it on a phone and my typeset is a little bit too small, let me know. It's kind of hard. Even my phone is kind of large, so it looks fine to me. But if you're having any issues, drop it in the comments. If you have any questions on any of this or any of the sessions that I have done or will do, I'd love to hear from you. But I'd also love to have you join the channel, hit the subscribe, hit the notify. I'm going to try to put out at least one a week, especially as I'm starting this channel. Maybe move a little faster later, but at least I'm shooting for once a week now. But fingers crossed we can hit that. But I appreciate you coming on this journey as I try to dump all my knowledge of 36 years and put it out there. So I hope you had fun with this, and until the next session, enjoy coding.